Hello and welcome. In this lecture we're going to be looking at how we can use the anim graph of an animation blueprint, this whole new concept, two new concepts, to blend animations together using a series of variables. As you can see, I'm changing the variables, it's changing the blend of animation. Let's dive in and see how this works. So we've got some semblance of animation here, but obviously it's not dynamic, it's not particularly interesting. We need to be able to do animations that are far more complicated than this. And Unreal has many great built-in systems to do this. The main one being the animation blueprint, which is a blueprint, obviously. So we're not going to be doing this in C++ because animations just make sense to be done in Blueprint. And the main point of the animation blueprint is to bring together all that animation logic and allow us to kind of blend and merge and switch between animations such that our game logic can then drive that animation blueprint. So without further ado, let's try and create an animation blueprint. So in the content browser, either add new or right click, and we're going to go to animation and select animation blueprint here. And you'll see right off the bat, it is asking us to maybe have a parent class. We don't need a parent class. We can just use the default, but it does need a skeleton. Because like the animations, like the skeletal meshes, they both rely on the skeleton, so does the animation blueprint, which means that then it can use all the animations of that skeleton and it can be used on any of the meshes that relate to that skeleton. Now, obviously, we want the Wraith skeleton here, so let's go ahead and select that and click OK, and that's going to go ahead and create an animation blueprint based off of the Wraith skeleton. And then for naming convention, we start with ABP underscore, and I'm going to call this the just shooter character, basically, because we've got that different prefix. I think it's clear enough. It's the animation blueprint for the shooter character. So if we go ahead and open up that animation blueprint and dock it to our main window, then we're going to see an animation blueprint editor, which in many ways looks similar to your usual blueprint editor. It's got this main graph area in the middle, but in some ways it's different. So we've got the graph area, that's similar. This is a slightly different graph to what we're used to. It's called the anim graph. You can see there's also an event graph, just like your regular blueprint. They have an event graph, but there's also something called an anim graph. We'll get to that in a second. There's a details pane, which gives you details about the animation blueprint. So the class itself, you've got the details on that. Notice we don't have any components against an animation blueprint. That's one difference to note already. We've got this anim preview editor, which allows us to do some stuff with this preview window over here. Why they're not closer to each other by default, I don't know. Asset browser, just like on the animations, allows us to look through animations easily, bring them in to our editor. And here at the top right, again, same as animations and meshes, we have this view that allows us to quickly switch between the skeleton, the mesh, and the animations, and the blueprints that all rely upon that same skeleton. Then over in the bottom left, we've got that My Blueprint pane, which is very much the same as My Blueprint on your standard blueprint. You've got your functions, your variables, macros, that sort of stuff is the same. What's different, oh yeah, we've got the graphs as well, that's also the same, but what's different is this animation graphs and animation layers. Now, we're not really going to touch upon animation layers, that's a bit more of an advanced feature that we don't need, but the graph, that is what is very important indeed, because the graph is kind of like blueprints, except we have no execution node. All we've got is the data that flows through the graph. And what does flow through the graph? Well, basically, we're trying to get to this output pose, this output animation pose that we should model our character into. And we do that by connecting up lots of different nodes to this result node, and flowing through that, we end up getting the data that is our output. One simple output that we can go with is, for example, just dragging in an animation into this anim graph, and you can see that it creates a node. And it has an output pin, which is an animation pose, and if we drag that pose onto the output pose and hit compile, you can see that it's just going to show in our preview what this animation blueprint does. It essentially just plays this ability animation. And that pretty much what we're doing at the moment, except now we put an extra layer in between. You know, we're putting a blueprint in instead of just playing the animation directly. That's not particularly useful in and of itself. But the different kinds of operations we can do on these poses, now that is useful. If we right-click in the anim graph, you can see there's a lot of stuff going on here. I want to search for something called a blend. And there's a few different things in here. Let's see if I can find the most useful one. We want at the top, there is a few here. I think blend bone by channel, blend multi. We want just the standard blend node. Let's bring that in. And you can see here we've got a value, we've got 2 input poses and 1 output pose. So what we can do is we can drag in 2 different animations. We can stick, this one's an additive animation. I don't want to bring that in. That's going to confuse us. Let's use some animations that we might actually use. So we were looking at the forward movement. We've got jog. Aha, jog might be more what we want rather than walking. So let's have a little look at our jog forward. That might be one thing that we can blend. And then the other thing we could blend is a jog back. So let's just look for jog. And we've got jog BWD, which I think stands for backwards, forward, backwards. Let's bring those into our blend node and then output them and see what the result's going to be when I hit compile. You can see I'm jogging forward. If I stick my alpha over to 1 and then recompile, you can see that now I'm jogging backwards. And you can see also as the preview runs, you can see which nodes, where the data is flowing, basically from the jog backwards through the blend node, and there's nothing coming through that pin A because alpha blends between the two. Now I can do a 0.5 on the alpha or anywhere in between, and that's going to try and play both of the animations and layer them on top of each other, half of both of them. And obviously when you're dealing with jogging forward and backwards at the same time, that starts to look a little bit funny, doesn't it? So what I'm going to do here is I'm going to remove the jog backwards and put in an idle animation instead. So where do we have idle? I'm going to select this idle non-combat and bring that in here. So that now what should happen is if we're at 50%, it's kind of doing this idle non-combat, half of that, and then half of the jog. Whereas if I put it at 1, it's going to do 100% idle, 0, it's going to do 100% jog. Now, this is not ideal, the fact that I keep changing this alpha, having to hit recompile. So what we can do is we can add in a variable to our blueprint. It needs to be a float. So we can go ahead and change the variable type in the details pane to float. And I'm going to change this to blend amount, like so. And then we can drag that in, so we can drag in any variables from our blueprint into the anim graph and hook it up to some of the pins, hit compile. And now if we go back to our anim preview editor, you can see that it's showing up these variables like that we've created over here, the blend amount. And that means that now if I can just shift that at runtime, I can see and preview what would be happening. And then basically what's going to happen is our game is going to drive these variables in the animation blueprint to get the right sort of animation at any particular point during playing. That's what we're going to deal with a little bit later on in this section. But for now, we're going to try and get this animation looking right when we have the right sort of variables in here. So it's time for a bit of a challenge. See if you can get set up with an animation blueprint and play around with the anim graph. So I'd like you to add another blend. We're going to add them up in sequence. So first you're going to do one blend, its output's going to go into the input of the next blend. Then select an animation that makes sense, such maybe as moving right or left, and add some variables that also make sense so that you can tweak them and look at the preview and you can blend between all of the animations, the idle, the moving forward, and your animation of choice, whether it's moving left or right, something like that. Pause the video and have a go. Just play with these blends, see if you can make sense of the anim graph. Okay, welcome back. So hopefully you've had a little go. We're going to go and add in another blend node. So search for blend, and then I'm going to scroll up for some reason. This might be to do with my screen scaling. Let's go to the blend and bring across, let's see, these idle animations, what do I want to do? I think I want to have it move left. So I'm going to look in my asset browser for jogging, and we're going to look for a jogging left animation. Now, by the way, I do know that blends are not the ideal way to do this. In the next lecture, we're going to look at a better way of doing this, which is going to be to use something called a blend space, which automatically allows us to blend movement animations in a very nice way. But we're doing this just to get the idea of the anim graph before we dive into more complicated things. So we're going to blend between, let's see, left and forward, I think. So left here, and we're going to copy, cut, or move the forward over to B here. And then we're going to patch that in, the output of the blend, into the input of the next blend, the one that does idle or not. Does this actually make sense? Let's think about the variables. What should the variables be called? I'm going to have one which is called forward, just forward, that's quite simple, and one which is called right or left, because we're choosing a left animation. It's also going to be a float. So one of the blends needs to choose between forward and not moving. So that's going to be, let's try and make that our first blend. We'll hook in the idle non-combat to A, so that at 0 alpha, it is going to be not moving. At 1, where forward is 1, let's hook up that forward variable to the alpha. At 1, it's going to move forward. Then we're going to bring that in to 0 of moving left. Hook that left variable up, 0 of moving left. And at 1 of moving left, we're going to hook up a B. Basically, we're going to hook up the jog left. So if we compile that, I was a little bit scatterbrained, but hopefully you get the idea. If we go over to the anim preview editor and we move forward, you can see that we start jogging. Reset that. And if we move left, you can see that we start moving left. And crucially, if we do both, move left and start jogging, we should see a blend, a little bit of both. Here we've got that forward being blended. If I need to have a little bit less of the left, 50% of the left, you can see I'm kind of moving. It's a weird looking animation. It's not blending it particularly well, but you can see that it's playing both the jog left and the jog forward. Now, as I said, we're going to leave these variables more or less intact, but we're going to change the mechanism by which we actually do the blending to make more sense and use more of those animations that we're seeing in the asset browser for jogging forward, jogging backwards, jogging left, etc. But that's all the subject of the next lecture. This one, we have covered more or less the animation blueprints and how the anim graph works and why we have it there in the first place. So I'll see you in the next lecture for more animations.